All right, so we are going on with part 4 of our formulas and nomenclature of PowerPoint. We're going to start learning about writing formulas for ternary ionic compounds. And of course, remember, ternary ionic means that it starts with a metal, usually. Now, of course, there is an exception to that. We could have one that started with our polyatomic cation, ammonium. But typically we'll start with a metal, and then connected to the metal will be the polyatomic ion. So let's write in a sample here. Let's do magnesium phosphate. All right, now how would I know that this is ternary? Well, I would know it's ternary because magnesium is a single element, and an ATE, that's one of our polyatomic ions, which we know has to have at least 2 elements. So that's at least 2 here, and 1 here, that's 3 right there. So that's how I know it's ternary. How do I know it's ionic? Because magnesium is a metal. It's alkaline earth metal. So let's see what we do here. We'll write the symbol for the metal first. I'll do that, Mg. And I write the symbol for the polyatomic anion. So if I look up on my charges sheet, phosphate, which is PO4, and it says to put it in parentheses. And we always do that with polyatomics. We may need the parentheses, we may not, but we put them around there just initially. Now we're going to write the charge for each one. For magnesium, it's +2. For phosphate, again, the charges you can get from your charges sheet, -3. Do they add up to 0? If they don't, you crisscross the numbers and leave the signs. The 2 will go on the outside of the parentheses. And because we crisscrossed here, we know that the parentheses are going to be necessary because I have to have a separation between this 4 and this 2. Otherwise, it would look like 42. So we crisscross the 2 there. We crisscross the 3 there. Again, we don't bring the signs with it. That's just to help us determine if they add up to 0 or not. And then I rewrite the symbols and the subscripts. And if I crisscrossed, I keep the parentheses there. If I didn't crisscross, if they added up to 0, parentheses aren't necessary. So there's Mg3PO4. That would be your answer for that practice problem. Okay. All right, let's move on. Let's try some other sample problems. All right, barium chlorate. Again, how do I know that this is ternary? Barium's a single element. Chlorate ends in ATE, and that means that it is polyatomic. So I write the symbol for barium, which is Ba. Chlorate is ClO3. Put that in parentheses because it's polyatomic. The charge for barium is +2. Chlorate's -1. Do they add up to 0? Well, they don't, so the 2 crisscrosses. It has to crisscross the outside of the parentheses. That 1 goes there. We don't write the 1s, though. 1s are understood. And our formula is BaClO3. And that is also a typo. So we should do this and that. So fix that. All right. Ammonium chloride. Now, this is one of those situations where you have to be careful. Ammonium is not a metal, but it's acting like a metal. We say that because it is a polyatomic cation. It's positively charged. So since it's a polyatomic ion, and I write NH4, I put it in parentheses. Now, the IDE here, what does that tell us about this ion? Well, it tells us it's monatomic. So chloride is just chlorine, Cl. Its charge is -1. Ammonium is +1. Do they add up to 0? They do. If they add up to 0, that means we don't crisscross anything, and we don't need the parentheses. So H4Cl is our answer. Silver sulfate. Again, why is this ionic? Because silver is a metal. So I write the symbol for silver, Ag. And sulfate ends in ATE, so I know it's a polyatomic ion. It's SO4, -2 charge. Silver is +1. Do they add up to 0? They do not, so the 2 crisscrosses here. The 1 crisscrosses here. Now we crisscrossed, but do we write 1s in chemistry? No, we don't write 1s in chemistry, so even though we did crisscross here, since the 1 isn't necessary, I don't need the parentheses. I do need the 2 down there though, so our answer ends up being Ag2SO4. Putting parentheses and putting the 1 out there is just a waste of ink or lead. Alright, iron 2 permanganate. Iron is Fe, so we write the symbol Fe. And what is its charge? Well, again, this is a situation. I taught you this earlier. Iron can be +2 or +3. How do I know which one it is? Well, if you see a Roman numeral 2, that matches the charge, so this is +2. Permanganate, MnO4, I looked that one up. It's got a -1 charge, put it in parentheses. Do they add up to 0? Yes, they do. So the 2 crisscrosses. The 1 goes there. We don't need 1s in chemistry though, so we crisscross them. And there's our answer for that one. Lithium nitrate. Lithium is Li. Nitrate ends in ATE, so I know it's polyatomic. I'll put it in parentheses. What's its charge? -1. What's lithium's charge? +1. Do they add up to 0? They do. Do I need the parentheses? Well, I don't crisscross here, so the parentheses are unnecessary. And it's just LiNO3. And last but not least, copper 2 phosphate. Copper is Cu, and copper can be +1 or +2. Which one is it here? Well, we see a Roman numeral 2, that means it's +2. Phosphate ends in ATE. I know it's polyatomic. PO4, I put it in parentheses temporarily. I may need them, I may not. Charge is +3. Oops, excuse me, -3. Does a +2 and a -3 add up to 0? Nope. So the 3 goes here, and the 2 goes here. We do need the parentheses to act as separation. And there's our answer. And again, this up here, make sure you realize there's a typo. Now again, guys, remember that notice the parentheses only go around polyatomics. I'm never ever going to have parentheses around a metal. So it would be wrong for me to put Ag and then a 2 there, or Cu and then a 3 outside that. That wouldn't make any sense. Alright, so hopefully that helps you with writing formulas for ternary ionic compounds.